Still working with resolvers in this video, and now we are going to perform a lock-in and verify alignment. So again, starting off from the minute screen, we are going to go this time to motor into our lock-in module. And if you watch the alignment video on the ABB3HAC motor we were working on, I'm using the same motor. So my drop-downs are going to be resolver. Again, the next two populate to generic, generic, the number of pole pairs of the motor, which in this case is 4, and the manufacturer of the motor, which in this case is ABB3HAC 8-pole. So again, just like in the analytics screen for the lock-in, we would want to verify our excitation parameters for the reference channel of the resolver, which again is defaulted to 6 volts peak to peak and 5 kHz frequency. Most of the time that will work with any resolver that you have connected. So usually you can just leave it just like that and click set parameters and then hit start collection. So it's always best practice, regardless if the alignment point is known ahead of time or not, to verify the alignment on an incoming motor. So the first thing we're going to do is click this alignment toggle like I just did and see what the lock-in sequence should be for this particular motor, this ABB3HAC 8-pole. And I have my motor power cable connected to the alignment, and I have the resolver connected to the linea. And I'm just going to rotate the shaft until we're close to mechanical angle 0 and electrical angle 0 here. And I'm going to follow this lock-in sequence of V positive, W negative to see how close this resolver is installed at that angle. Okay, pretty close. Yep, kind of right in the wheelhouse. This is a larger motor too, so I may have to adjust the shaft a little bit just to make sure I'm getting an accurate reading. And since this is a 4-pole pair motor, I should see that alignment point true and that electrical angle 0 at 4 points and 1 mechanical angle. And that would be the 4th point, 90 degrees there. So if this were an incoming motor and I wanted to check to make sure that it was aligned properly according to the AutoCue software, I can be assured that the lock-in sequence is correct, the V positive, W negative, and that's how it was aligned. And I'm okay to remove that resolver. Knowing that that is the angle that I'm going to realign it once I have it rebuilt and I'm ready to reattach the resolver. All right, so let's pretend we did remove the resolver. It has been rebuilt, or the motor has been rebuilt, and we're ready to reattach and align this resolver. Resolvers are pretty easy to align. The only tricky part is you're not going to start getting good mechanical angle and electrical angle values until you have that outer ring, those windings around the resolver core. So as long as you have the resolver connected, you'll be able to lock in the rotor through the alignment and the power cable, just like we did checking the initial alignment. So V positive, W negative. And then I would set the resolver on the rear, line it up until it showed electrical angle 0 degrees. And I would secure it with those 3 set screws on the back of the outside of the resolver to make sure that the alignment point stayed true. And once I have that resolver secured and that alignment point light is staying true and I'm close to my electrical angle 0 degrees, then this resolver is now aligned and I'm ready to move on to final testing. Thank you very much for your time, and we are always available to help. Just shoot us an email at support@octavaengineering.com, and I thank you very much for your time.